wanted to introduce Dr. Sarah Ballantine, who I'm informed is now a New York Times best-selling author. And she'll talk about lifestyle and autoimmune disease.
Thank you. Can you guys hear me? Oh, yeah, I can hear me. So clearly you can hear me. Thank you so much for sticking out for the last talk of the day. So there's been like amazing talks, and now I'm supposed to be this big grand finale, so like no pressure. I'll do my best. I'm gonna start with, if you guys know, I have this little ritual I like to start every talk with. I like to take a picture of you. And this is kind of my way of like remembering the lovely day, the lovely afternoon we're about to spend together. So if you guys could all pretend, because I can't do this in the middle of the talk, I have to actually focus on what I'm saying. If you could pretend like I'm in the middle of the talk and I'm saying something like groundbreakingly interesting, you guys can't believe this like super cool information I'm giving you, it's like changing your lives. And now if you could pretend it's like the end of the talk and it was like the best talk you've ever been to, and you huge round of applause. Come on guys, like you gotta like, feel free to give a standing ovation. Maybe my talk's gonna be that good, you're gonna wanna do a standing ovation. Like feel free, come on, up. Remember, sitting is death. All right. Thank you very much. I believe my talk is done. Oh no, wait, I still have to do it. If you've heard me talk recently, you know that I've been on a bit of a nutrient density bandwagon lately. And I've been talking a lot about nutrient density. Today I'm actually going to talk about something that's very parallel to this focus on nutrient density, and that is really the direct effect on gut health that our lifestyle choices have. Now, if you haven't heard me talk lately, you might not know who I am. I'm Sarah Ballantine. I blog at The Paleo Mom, and I was a medical researcher. I have a Ph.D. in medical biophysics. I did 4 years of postdoctoral medical research in critical care medicine and epithelial cell biology before I had my first daughter. And I decided to take a break from medical research, in large part because I wanted to be the perfect mom. Yeah, that ship has sailed. But also because I was morbidly obese, and I suffered from 12 different health conditions, and I was having a really difficult time finding work-life balance. So I focused on life. And that also allowed me to focus on my health. And my health journey eventually brought me to a paleo diet. It managed to reverse all of my diseases. I discontinued 6 prescription medications. It contributed to my 120-pound weight loss. I credit the paleo diet and lifestyle for now being in the best health that I've ever been in. So my perspective when I talk about these topics comes both from my science background and my just inherent geekiness and desire to understand the detailed mechanisms of how my choices are working, but also my passion and my personal experience with living this and changing my life with these types of choices. So if you're like me and you had an autoimmune disease or 2 or 3, and you've come to the ancestral health movement, you've come to a paleo or a primal template in order to handle your autoimmune disease or other immune-related diseases, you're probably familiar with the paleo autoimmune protocol. So this is a more restrictive version of the paleo diet, and I really don't like using the word restrictive, even though it's technically true here. I prefer to think of it as a more specific version of the paleo diet, because what it does is it not only removes some foods that have immune-stimulating compounds in them that can be a problem for those of us who are more genetically susceptible to react to those foods, but it also changes our focus to an even greater focus on nutrient density. It encourages us to eat more organ meat, more seafood, more vegetables, to seek out the best quality foods that we can, and to also incorporate a large amount of variety in our diets. We do this, of course, with avoiding a few good foods like tomatoes, nuts, seeds, eggs, and that can be really challenging. We also have more of a focus on moderation when it comes to things like fructose, omega-6 polyunsaturated fats, caffeinated teas, coconut. All of these dietary choices, let's use the word choice here, they all come from our understanding of how food interacts with our body. And they are really targeted at immune regulation. So when you have an autoimmune disease or an immune disease, actually any chronic illness, One of the things going on there is that the immune system is not regulating itself properly. And so we make these diet choices based on regulating the immune system, and they do this in 3 ways. The first is nutrient density. So we're providing our bodies with the nutrients that the immune system actually needs in order for its regulatory mechanisms to function properly. It also provides us with the nutrients that our bodies need to heal damaged tissues. We're also making diet choices based on hormone regulation. So we're regulating insulin and insulin sensitivity, leptin, ghrelin, cortisol. These are all affected by our diet choices, and their regulation is really, really important when it comes to the immune system because all of these hormones directly impact how easily stimulated the immune system is, how turned on it is, how well regulated it is. So we need to regulate these hormones in order to regulate the immune system. And then probably what is one of our biggest focuses in the paleo movement in general is gut health. And this is incredibly important when it comes to autoimmune disease because a leaky gut, or more technically, increased intestinal permeability, has been found in every autoimmune disease in which its presence has been investigated. Similarly, gut dysbiosis has been found in every autoimmune disease in which its presence has been investigated, and leaky gut and gut dysbiosis seem to go hand in hand. So this has led to the hypothesis that a abnormal gut environment, whether that's increased intestinal permeability, gut dysbiosis, or the combination, may be a prerequisite for autoimmune disease to develop. So that means not only do you need this genetic predisposition and you need a trigger, but you need a leaky gut, or you need a damaged gut, or you need the wrong kind of bacteria, or too many bacteria, or not enough bacteria growing in your gut. There has to be something wrong going on there. And when you consider that 80% of our immune system is housed in the tissues around our gut, it starts to make some sense that gut health would be really, really important to the development of autoimmune disease and also to the management of autoimmune disease using diet and lifestyle. But here is the crux of my talk. Gut health is not just about the food choices you make. And as you embark on this really specific diet, this diet that requires a lot of effort, it becomes even more important to focus on the lifestyle factors that impact gut health, because you're going to all this effort. You are working so hard to make the right choices. You're doing all of this cooking. You're going out to farms. You're spending more money on your groceries. And if you don't get these lifestyle factors in place, you may not see results for your effort. And I can tell you there is nothing more frustrating than putting a ton of effort into your diet, feeling horribly deprived, and not seeing a benefit from it. A huge variety of lifestyle factors actually directly impact the health of the gut. This is not indirect, this is direct. And what I'm going to talk about today is how stress, how much stress you're under, how well managed it is, how much activity you do, what type of activity you do, and also how well entrenched your circadian rhythms are and how those directly impact gut health. So if I'm going to talk about gut health, it's probably good to do some basic physiology right now. When I'm talking about the gut, what I'm really talking about is the small intestine. So the small intestine is that big tube that joins your stomach to your large intestine, which is another big tube. The small intestine is longer and smaller in diameter, hence the word small. And this is where basically the majority of digestion occurs. And this is where the majority of nutrient absorption occurs. So it's an incredibly important organ. And if you think about this, if you didn't have a small intestine, if your small intestine is not working properly, you can't absorb the nutrients that every tissue in your body needs. This is a vital organ. We need our small intestine. And it's actually a pretty cool organ, except for the part where it's full of gross stuff. It has a structure that is designed to increase surface area. And actually, every time you magnify, you look at it with a microscope and you look closer and closer and closer, it still has structures that increase surface area. So it's these structures that fold upon these structures that fold upon these structures that fold. And if you actually unfolded the entire small intestine, you would have a surface area about the same size as a tennis court. So think about that for a second. Your small intestine inside your body, you unfolded it, tennis court. That's pretty big. So the largest structures are called the plicae circulares. These are the macroscopic folds, the ones that you could see if you were actually looking at someone's small intestine, which I hope you're only doing under very controlled conditions. When you look more microscopically than that, you see these structures that are like columns. They're often described as hills and valleys, but they're like Dr. Seuss hills because they're really, really steep. They're more like bunch of fingers together. They're called villi, and the valleys are called crypts. These are actually the dominant structure that really gives surface area to the small intestine. And they're really, really important. This entire surface is really formed from one continuous sheet of a highly specialized type of cell called an epithelial cell. These cells are, I've studied epithelial cell biology, so I can tell you from I spent 2 hours studying these cells, or 2 years studying these cells. They're super cool. I never, ever got bored. Yeah, right. Epithelial cells have a top and a bottom. And that's really, really important because not every cell in your body has a top and a bottom. So the top, which is called the apical side, and this is when we're talking about the gut epithelium, is the side facing inside your gut, which is actually outside your body. I know, mind blown right now. This apical side of the cell membrane has, again, structures designed to increase surface area. They're more microscopic than villi, so we call them microvilli. And again, they're sort of finger-like projections. And their entire purpose is to increase the amount of outside of the cell that the cell can interact with. The rest of the membrane is a different structure. It doesn't have these microvilli. The rest of the membrane, we lump the sides and the bottom together because the cell doesn't really know the difference between sides and bottom. It's called the basolateral membrane. The cell has a very specialized structure that helps it know the difference between its apical membrane and its basolateral membrane. And this structure is very relevant to everything I'm going to be talking about today. It's called a tight junction. Tight junctions are essential for epithelial cell health. And in fact, if you take epithelial cells and you grow them in a petri dish and you do something to them to disrupt their tight junction, they turn into cancer. So tight junctions are phenomenally important for these cells to maintain what's called cell polarity, which basically means the cell can keep track of which side's the top and which side's the bottom. It's also really important for the integrity of the epithelial barrier. So these tight junctions actually control how easy it is for substances to cross that epithelial barrier, and that's really what we're talking about when we talk about leaky gut. We're talking about the epithelial barrier no longer being able to control what crosses it. I want to show you just a little bit of how complex these tight junctions are. They're phenomenally important, and I have done a lot of microscopy staining for these proteins in the past. It's generally a structure made up of a transmembrane protein, so proteins that start from the inside of the cell, go through the membrane, and end up on the outside of the cell. And they're very tangly, bent proteins, and they kind of interlock, and they form like a knot. Now, if you can think of a knot, you can loosen the knot a little bit. That opens the tight junction and allows some things to travel through. You can close that knot, tighten it. And now you've closed the tight junction, and now things can't travel through as easily. The tight junction is a highly regulated structure within the cell. The cell has dozens of proteins that help control how exactly all of these proteins link so that it can control how open or closed the tight junction is. It is a dynamic structure. So it's not permanently closed. The cell actually opens and closes it in a controlled way to purposefully allow substances to travel paracellularly, which means between the cells, across the epithelial barrier. And I love showing transmission electron microscope images because they're pretty. This is the top of the cell. So these are actually the microvilli. This is two cells side by side, and they would go straight through the floor. That's how magnified that we're looking at them. And this dark area right here is the tight junction. What makes it dark on electron microscopy is the density of proteins that are there interacting with each other, forming this really complex. And it's integral to the integrity of an epithelial barrier. So when we're talking about gut health, we're really talking about epithelial cell health and how well controlled that tight junction is. So how well the cell can actually decide whether or not that tight junction is open or closed. And I'm going to start with stress. It is well known that stress increases intestinal permeability. It is well known that stress decreases digestion by decreasing gut motility, decreasing mucus production, inhibiting pancreatic secretions, inhibiting gallbladder function. It inhibits the gut immune system, and because it slows down digestion, it changes the environment for microorganisms. It is permissive for gut dysbiosis and overgrowth. So stress is a big deal, and this is fairly well understood. But what's really important to understand when we're talking about stress, we're not just talking about, a lion is chasing me, or I'm stuck in a traffic jam, which really our bodies see as being the same thing. It is activation of the hypothalamic pituitary adrenal axis, or the HPA axis. So the hippocampus is the area of the brain that really assembles information from our senses and kind of goes, okay, wait, there's a lion, or bad traffic. It sends signals to the hypothalamus, which is really the area of the brain that has a lot of control when it comes to hormones. The hypothalamus is really like the hormone controller area of the brain. The hypothalamus goes, great, lion, we got to do something. And it releases corticotropin-releasing hormone, or CRH. Corticotropin-releasing hormone goes to the pituitary gland, which sees it and goes, oh, lion, or traffic jam. Time to get the adrenal glands going. So it releases, and please only make me say this once, adrenocorticotropic hormone, or ACTH. I'm going to ACTH from now on. This is just too many syllables. And ACTH travels to the adrenal glands and says, hey guys, time to get going. And adrenal glands release all the things that they release. So that's cortisol, which is going to be most relevant to our discussion today, but also catecholamines like adrenaline. Now, what's really important about the HPA axis is that there's a built-in control. When cortisol is traveling through the blood, it sends signals back to the pituitary gland and to the hypothalamus that, okay guys, we got the message, we understand traffic jam or lion, we're on it. And cortisol is really important for diverting resources to the brain for heightened decision making, and to muscles for running away from the traffic jam. And so it's telling the brain at the same time that it understands that we've got this stress and we're doing our job. And I'm going to come back to that negative feedback in a second. Let's start with cortisol. We think of cortisol as the master stress hormone. So clearly cortisol has a role in everything. It has actually a very important role in gut health, but maybe not the role that you're thinking of right now, because cortisol actually regulates tight junctions and it tightens them. So we think of stress increases intestinal permeability, but cortisol actually decreases intestinal permeability. How is that working? Well, cortisol is actually a natural hormone. As much as it's part of the fight or flight response, it's also a circadian rhythm hormone. It's also a metabolism hormone. It helps us access stored energy between meals. So it's really important to understand that cortisol has these normal roles in the human body, and one of them is very, very likely helping the gut epithelium to regulate absorption of nutrients after a meal when it's low, and it allows tight junctions to open, and between meals when it's higher and tight junctions are closed when there's not necessarily things to be absorbing. The problem is when cortisol is too high or too low. So too low might happen, an example for Addison's disease or chronic adrenal insufficiency, or what we lay people call adrenal fatigue. When you've gone so long, going so high, that your adrenal glands have basically said, like, okay, we're done, we quit, this is not the job we signed up for. And now your body is chronically producing too low of cortisol. I have extensive personal experience with this. And then what happens is that actually opens up the tight junctions, it causes leaky gut. So adrenal fatigue in that burnout phase, just automatically by the nature of having low cortisol, causes a leaky gut. So normal high cortisol is good, but then really high cortisol, again, it alters the structure of the tight junction, but now in a more complex way. So it's not as simple as saying, oh, it makes it leaky again. It makes the tight junctions more permeable to small molecular weight substances, so small things can cross, and it makes it less permeable to high molecular weight substances. So there's a give and take there. And the details of exactly why and what the impact in that is still something that's being studied. But when we're talking about cortisol, a lot of the studies, how we understand the effects of cortisol is by adding exogenous cortisol. And we do that by treating with steroids, like prednisone. And what we know is that when somebody's having an autoimmune disease flare and we treat them with steroids, it actually tightens up the tight junctions and it decreases intestinal permeability. That's one of the reasons why prednisone can be a life-saving medication during an autoimmune flare. And it does this, and this is the really important part, through glucocorticoid receptor binding. So cortisol has its effect through binding with a variety of different types of cortisol receptors throughout the body. And it's this binding that is responsible for the action on tight junctions. And this is really important because when you're under chronic stress, in a situation that's completely analogous to loss of insulin sensitivity, when you're eating way too much sugar and your insulin's chronically high, and then eventually your cells just aren't as sensitive to insulin, you have insulin resistance, we have cortisol resistance, or more technically cortisol receptor resistance. And that is one of the detrimental effects to chronic stress. And so even though your cortisol may be high because you're chronically stressed and your adrenal glands haven't given up the ghost yet, you may be causing a leaky gut because you've got cortisol receptor resistance. And this is something that is still a hypothesis that has not yet been investigated. But the HPA axis, as I already described, as much as cortisol is important, it's not all about cortisol. And I want to talk about corticotropin-releasing hormone, or CRH, because its impact on gut health is probably more profound than cortisol. And this is really interesting to me because when you talk about adrenal burnout, when you talk about adrenal fatigue, you're not producing enough cortisol, you're also losing that feedback. So what happens is you're stressed. So you've been in traffic for a really, really long time, and now there's an angry driver behind you, and it just like totally is the worst day ever. Your coffee spilled on you, your kid cried when you left the house, awful. Your adrenal glands have given up. So your brain is perceiving stress. It's telling your hypothalamus to produce CRH. Your hypothalamus is telling your pituitary gland to produce ACTH. The ACTH is telling your adrenal glands to produce cortisol. No cortisol is being produced, so you're not suppressing that system. So you keep producing more CRH, more ACTH, and these are hormones themselves, and they have an impact themselves. They're not just in that one line of signaling. So in particular, CRH increases epithelial permeability in every epithelial barrier that it's been tested. So that's gut, lung, blood, brain, and skin. And a leaky epithelial barrier is never a good thing. Now it does this in two ways. It does this through an action on the tight junctions themselves by changing the type of proteins that are involved in it, and it actually changes it to one that's not able to create such a tight knot compared to other protein options. It also does this indirectly by activating mast cells. Mast cells are an immune cell type that are present in just about every tissue in your body, and they're actually the cell that is really responsible for allergic reactions. They produce histamine, they also produce heparin, which is a blood thinner, and a variety of pro-inflammatory cytokines. They're really kind of one of the cells that sort of get things going. So there's a direct effect on tight junctions and a further effect on permeability by activating mast cells from CRH. So when we talk about the HPA axis and how this is important for gut health, what we're really talking about is the gut-brain axis, which is certainly one part, the hormone part of the gut-brain axis. The gut-brain axis is also much more complicated. It involves cytokine signals and it involves nervous signals. Now, what happens when you are stressed, depressed, experiencing strong negative emotions, is that the vagus nerve output is decreased. So the vagus nerve innervates most of the thoracic and abdominal cavities. So that means that it branches out into the nerves that control all of your organs that are part of your digestive system. And so when that output is reduced, you end up reducing digestion. You lower stomach acid production, you reduce the secretion of pancreatic enzymes, you inhibit gallbladder function, you decrease gut motility. All of these things that we said chronic stress does. It's not just a hormone effect, it's also through a direct effect through the nervous system. And when you suppress digestion, you again create an environment that's permissive for gut dysbiosis and overgrowth. But the connection between the brain and gut health is even more complicated because it also involves circadian rhythms. In particular, it involves melatonin. So melatonin is the sleep hormone. Our bodies produce melatonin. It's the pineal gland that produces it. It's secreted into the blood about 2 hours before you go to bed. lowers body temperature, it slows down your metabolism, makes you feel sleepy and happy, and it prepares the body for sleep. Melatonin, though, is also produced by the tissues in the gut. And in fact, there may be 10 to 100 times more melatonin produced in the gut than produced in the pineal gland. And the gut itself can house about 400 times more melatonin than the pineal gland can. Melatonin is one of 2 neurotransmitters that regulate gut motility. So it's serotonin and melatonin, they work together. So that really very important peristaltic action of your digestive tract to move stuff down is regulated by melatonin and serotonin. The gut further is probably important in how your body clears melatonin. So your pineal gland releases it in the evening, you go to sleep, your melatonin eventually leaves the bloodstream. Where does it go? It actually is sequestered by the tissues in the gut. And so you need that to be able to work normally. So what we know is that melatonin decreases intestinal permeability through direct action on tight junctions. But if you are supplementing with melatonin to support sleep, that long-term supplementation with melatonin has the opposite effect. We don't exactly know why. Probably because your endogenous production is different and exogenous is typically different. Melatonin production, both in the brain and in the gut, is influenced by circadian rhythm. So it's influenced by sleep cycles, how well entrenched your sleep cycles are. Do you go to bed at the same time every night? It's influenced by the light-dark cycle. Are you being exposed to bright light during the day? Are you sleeping in the dark at night? It's based on, it's the amino acid tryptophan. It's just 5 steps away from tryptophan. So it's also based on nutrition. If you're not getting adequate tryptophan, then you are really not able to make enough melatonin. And it also has an indirect effect. So we've got this great direct effect from melatonin. It has this indirect effect because when you support melatonin production, melatonin is another circadian rhythm hormone, as is cortisol. When you support your circadian rhythms, you support normal melatonin production, you also reduce activation of the HPA axis, so you're reducing stress, so you're promoting gut health that way as well. I drank in front of a room full of people and I did not pour it down my dress. It's a win. So I think that when we talk about stress and we talk about its impact on the gut, it's a pretty easy thing for people to wrap their heads around. I mean, there's some extra like, oh cool, I didn't know that CRH did that. That's really neat. But it makes sense to us. And it makes sense to us in part because when we're stressed, we tend to feel it in our abdomens. If you're really stressed, you might feel nauseous, you might have loss of appetite, you might have increased appetite, depending on the stress. You might have sort of butterflies in your stomach or that feeling. And so this idea that there's a direct impact on gut health from stress is not such a challenging concept. But it maybe is a little bit more of a surprise to know that how active you are and what types of activities you engage in also has a direct impact on gut health. Now, physical activity also has indirect effects because being physically active helps reduce stress. So it actually makes you more resilient to stressors, so you have less HPA axis activation when you're under psychological stress. So physical activity is phenomenally important from that standpoint, from hormone regulation and the effects that those hormones have on gut health. It's also entrenched with circadian rhythms. So when you're physically active, you're supporting melatonin production. So there's all these indirect effects through the mechanisms that I've already described. But there's also a direct effect. And the direct effect is not so much from being sedentary, it's from being overactive. So we know that being sedentary is really horrible for your health. In fact, the World Health Organization lists physical inactivity as the 4th leading risk factor for global mortality. It's like one of my favorite statistics. So just sitting on the couch all day is one of the worst things that you can do for your health. But being overactive can actually be very damaging to the gut. If anybody here has done any endurance training, marathon running, anyone run a marathon? Oh my gosh, really, you crazy people. I've run marathons too, so I'm with you. There's this thing called runner's runs, runner's trots, the gingerbread man, run as fast as you can. And it's a joke within endurance training. You know, you plan your long training runs, you know, where every bathroom is on the way. And it's characterized by extreme gastrointestinal distress, typically diarrhea, while training. And it is a symptom of something far more profound that's happening inside the digestive tract, which is injuring the integrity of the gut barrier. This also happens in other endurance athletes. It happens in cyclists, triathletes, and it can even happen in bodybuilders, so people who are doing really high strain activity that's not technically endurance activity. High intensity interval training can do the same thing. And it actually increases intestinal permeability via a direct action on the tight junctions. This is different than the stress response. So clearly, when you're doing these super intense of training exercises, you're doing super intense physical activity, it's a stress on your body. And we know that cortisol increases. But the action on the tight junctions is actually via heat shock proteins. So it's actually a different system than the HPA axis. And it's increasing tight junctions. We also know that prolonged intense activity diverts blood flow from the intestines. It's part of the fight or flight that is cortisol dependent. And it's because digestion is really not a priority when you're in the middle of an 18-mile run. Now, one of the things that runners do, and a lot of other endurance athletes do, is they try to fuel their activity by eating, and that's one of the worst things they can do because their digestive system's already not getting enough blood flow. The tight junctions are already opening, and there's actually a type of anaphylactic allergy that endurance trainers experience because of this effect. It's made worse by NSAID use, so as many endurance trainers are very fond of their Advil, that's actually making this effect worse. And it's making it worse when you're exercising in the heat. So if you're doing this in the summer compared to the winter, you're creating an even leakier gut than you would if it's cold outside. And very importantly, there's the cortisol effect from this type of training, but there's also a direct effect on gut health. And I actually want to read you a quote from the abstract from this paper, which summarizes all of the research to date on how exercise regulates tight junction assembly. Tight junction integrity is altered by the phosphorylation state of the proteins occludin and claudins and may be regulated by the type of exercise performed. Prolonged exercise and high-intensity exercise lead to an increase in key phosphorylation enzymes that ultimately cause tight junction dysfunction. And what this really means is that we see this type of tight junction dysfunction, these tight junctions opening and the gut becoming leaky from different kinds of intense exercise, whether it's prolonged exercise or really intense bodybuilding training, high-intensity interval training. We see this effect. And the effect may be slightly different. The details of the mechanism are very likely slightly different, and there's probably details that are different from individual to individual because a lot of how you respond to something like this is going to depend on how well managed stress is in your life, how much sleep you're getting, what your nutrient status is. But it is definitely something to be wary of. If you are looking to regulate your immune system, you want to make sure that you're active because being sedentary is definitely a problem, but you want to make sure that you're avoiding this type of really intense activity. So the take-home message is that gut health, while being clearly profoundly impacted by your choices of food, is also impacted by how well you manage stress, whether or not you're able to reduce stresses in your life, how active you are, what types of activity you are doing, and how well entrenched your circadian rhythms are, and that these lifestyle factors actually interact with each other. It's not just that they all dump in on gut health, but how clean your diet is actually influences your stress response. If you're getting adequate tryptophan, that makes it easier to produce melatonin. If you're being active, that also helps improve your stress response. So all of these things are interlinked, and they really need to be thought of that way when you're approaching your choices in order to manage and ideally reverse disease. So just to end on a bit of a practical note, what does this actually mean for day-to-day living? When it comes to managing stress, I highly recommend taking up meditation practice. It has been very well documented in the scientific literature to reduce cortisol production, help regulate hormones. This is not some airy-fairy granola idea. This is science, and it's fun. It's really important to have fun, to play, to smile, to laugh. It's really important to get enough sleep consistently every single night and to have a sleep routine so you have a bedtime, not just your kids, but you have a bedtime. It's important to be active, to include as much light activity in your life as possible. Things like walking, yoga, play, anything that you find fun. It's important to be in nature, and it's important to connect with others. These are all things that help reduce the stress response, so it improves our resilience to stress. And in addition to working on our resilience to stress, we also want to try to reduce stresses in our life. And that's an individual situation that every person needs to work out for themselves. When it comes to supporting circadian rhythms, you want to be getting exposed to bright light, ideally sunlight during the day, but any blue wavelengths of light will do. And you want to be in a dim environment in the evening and in dark at night. And by dim and dark, I mean no blue light. And you can hack this by turning down your lights in your home and wearing amber tinted glasses. Those are the yellow safety glasses. They block out blue light, and they're an awesome fashion statement. Scientific studies show that wearing them 2 to 3 hours before you go to bed dramatically improves sleep quality. And they cost like $8. Go to bed early. You have a bedtime. Your kids have a bedtime, you have a bedtime. Turn off Facebook. Unless you're looking at my page, then by all, no. Sleep in a cool, dark room. Do things like cover lights in your room. So if you have, like I have baby monitors still beside my bed, even though my kids are 7 and 4. Let's not get into it. But I have duct tape over the LED lights on the baby monitors so that I hear their white noise machines. It's quite soothing, but I don't see any light. Be active during the day. So yay, another point for activity. And make sure your evenings are relaxing. So try not to work in the evening. Try not to watch horror movies. So some of the things that you think you're doing to de-stress is actually activating your HPA axis. So be really picky about your evening activities. And then when it comes to being active, you want to be as active as possible while avoiding these high-strain activities. So avoid sitting for prolonged periods of time. If anybody wants to stand up right now, it's like totally cool. If you're working at a desk job, a standing desk or a walking desk is a great idea, but also just getting up every half hour and walking around, stretching your legs, getting your blood flowing. Even if you're at a standing desk, you actually still want to take every half hour to really change your body position. Maybe just squat or bend down and stretch your legs a little bit. That's actually still really important. All the little tricks that we see that is all over every media, like parking farther away and walking or taking the stairs instead of the elevator. These are all really important, and it's one of the things that the government is really getting right in terms of recommendations. And play. Do something fun. Playing is really important. It's active. It has all the right hormones. It reduces stress. It's amazing. Body weight exercises, walking is the classic. So anything that's moving your body weight around and anything that's going to build strength. Those are really, really important for regulating all of these hormones and for supporting gut health. So I hope that I have inspired you to critically look at how lifestyle is impacting your gut health. You can get more information in my books and my blog. I'm doing a book signing tonight at Barnes & Noble Emeryville at 7 o'clock. So I would love it if you guys can come out. And thank you very much. No standing ovation. See, I was good. It's good I got it at the beginning.